it hadn't turned red yet. There it goes. When I started this class in the first week, and first of all, this is not directed toward this class. I have 6 classes, and I would say probably 80 to 90 students. And I'm talking about probably 6 to 8 emails that I received this weekend that has constituted this rant. Okay, the first thing I'm going to talk about is the emails that I got. I'm trying to find it. Hold on. I don't know what I did with it. And the emails consisted of, here we go. There's my rant. The emails consisted of, Hubert, there was 2 types of emails. Hubert, I just took the unit whatever test, and there was 5 problems on the test, and I believe I got them right, and here they are. Here's a picture of them. I'm going to write them down. Here they are, however they sent them. I didn't know who sent them because I deleted them. Why did I delete them? Why did I delete those emails, text messages, Teams messages about challenging on a test? What are you supposed to do when you want to challenge a test question? Okay.
Ask to meet after class.
Ask to meet after class. Is that not what I told y'all? I mean, not y'all, but students in general. And I get out of, and again, I'm only talking about 6 or 8 students out of 90. Okay, I know I'm talking to 10%. Come on, people. Follow the directions. You know, the bonus question says,
yeah, I was about to say it's a bonus question.
Challenge
too.
I
was about to say it's a bonus question too.
It is.
They would know if you're taking a test, right?
And some people are on their 3rd test. Y'all are fixing to take y'all's 3rd test. The second thing I had a couple of students complain about, oh, I'm just not getting the material. I have to hire a tutor. I don't know how to use my calculator. What do I tell students to do if they don't understand something?
Ask a question.
Send me a question. I looked at a couple of these people that said that they wasn't understanding. You know when the last time they did homework? October 1st. So what's my dilemma here? Why am I ranting over somebody that says they don't understand the material, and I look back and their homework is October 1st? What's my dilemma here? Okay, nobody's going to say nothing. I want some of your help, you know.
Homework should have already been done.
So you can send what?
Questions.
And I can answer them.
Correct.
No, I used to do this after I had that bad teacher at Southwood. I would just do the homework whenever the test would be around, and I would try to get it all done. And then when I couldn't get it all done in one night, I'd get frustrated and I'd lash out. Been there, done that. I know what these people are doing. So, and I got to tell these people, and tomorrow, this is my 3rd class I've gone through this rant, and tomorrow I'm going to go through it 3 more times. Okay? My classes, and I've told y'all this the first couple of weeks of class, my classes are designed when you do the homework, you send in questions, I go over the questions. If I don't get questions, I what? I move on. The speed of the class is gauged by the students sending in homework questions. You can't send in homework questions if you hadn't done homework in 2 weeks. Now, I don't think I'm talking to anybody in here because I checked everybody's homework and y'all look like y'all are up to stuff. And I turned on the 6.6 homework. I thought it was turned on the other day and it wasn't, so I turned it on today. So I had one student, and I told you this student said that they didn't know how to do the calculator. Don't I show people how to use the calculator in class? Well,
yes, you do.
Yes.
But let me ask y'all, what do I also do to my class that helps students? I record them and I put them on what? YouTube. Can somebody tell me the feature that you can use on a recording? If you don't understand something, what can you do?
Stop and rewind.
And rewind. And on the case of using a calculator, if you don't understand the steps, can't you rewind it and go over the steps until you got all the steps down?
Yes.
I guess do I have a right to rant? And I think I do.
Yes.
Okay. All right. Now, announcements. Rant is over. 2 or 3 announcements. Here is one announcement. And you might not need this, but I'm announcing it to all my classes. These are 4 out of my 5 or 6 classes that I've been assigned for in the spring. Some of you, again, most of you are 2-year college students, but some of you might need another class later on, and you might want to take it next semester. Some of you may be 2-year degree nursing that might need 103 and 120 in the future. Okay. And in fact, the next unit, which I'm going to skip unit 3 and go straight to unit 4, and we'll do unit 3 if I have time. Unit 4 is the first 2 chapters in 120 and 103. So when we do unit 4, that's 2 units in 103 and 120. So, you know, it's something to think about. You don't need to worry about 155 and you don't need to worry about 130. But, you know, I don't know what you've talked about with your advisor or what your majors are or whatever. But if you need another math in the future, chances are it's going to be like the 120 or the 103. And if you're going to work after you graduate, then you don't need it at all. But I just wanted to mention that to you. There was one other announcement. Oh, the other announcement is I'm going straight to unit 4. So that's 11 and 12. I'm going straight to unit 4 after today. Okay. I'm going to leave unit 3. I'm going to leave it for the last test because it's a whole lot better if you know this, because some of you may be going to 103 or 120 in the future. This is more important than this. And I'm going to put this on autopilot. I'm going to open up all the homework and the test as soon as we open this up. I'm going to open up both together. And a lot of people can go ahead and do this. Why? Well, what is the perimeter of a square? What is the perimeter of a rectangle? What is the perimeter of a triangle? I think a lot of you know a lot of this. What is a stop sign? A stop sign is an octagon. Or what is a pentagon? 5 sides. What is an octagon? 8 sides. And there's a lot of, I don't want to insult your intelligence in this chapter, in this unit. So what I tell students, I make a deal with students. I will open this up for 2 units for the remainder of the semester. You work on it as you see fit. You do as much as you can. And then after we finish unit 4, which is probability and statistics, you can start sending me questions on unit 3. If you do all of them, you make 100, take the test. Make 100, then you can, after unit 3, after probability and statistics, you just wait for the final exam. So I'm going to leave, I call unit 3 autopilot. So when I open up the Unit 4 material, I'm going to open up the Unit 3 also. I will cover Unit 3 with the remainder of the semester after Unit 4. Does everybody understand that? Okay, again,
Yes.
out of all this is probably the easiest mathematical chapter. Okay, this is stuff that you learned back in pre-algebra, right before pre-algebra. Length and standardized metric, switching from metric to millimeters to meters. So there's a lot of stuff that y'all know. And if you don't know it, after chapter 4, send me the questions. After Unit 4, after we get through with statistics and probability, after we get through with this, start sending me the questions that you have that you can't do on this, and we'll start. And I'll just put them in order, and we'll start from the questions and cover most of the questions. So I'm really going to need input on this unit, because I ain't going to cover. If you don't send it, I'm not going to cover it, because I think most of y'all know what a pentagon is. And I'm not going to go through 8.2. I mean, if I had to go through 8.2, I think everybody ought to know what a square and a parallelogram is, and a pentagon and an octagon. You know, most of y'all know, and most of y'all know how to find the perimeter and area of a rectangle or a square or a triangle. But we'll go over whatever you don't know. There are some areas in here that you may not be familiar with, but there's a lot more that you are familiar with. Okay, so that's the announcements today. All right, we are going to go over the last part of the graphing section. And that is these pages right here. The last 3 pages. Start with, get your get your handout. Graphing, part 1, rules and properties. Okay. Now, it's going to be graphing part 1, rules and properties. That's it. I used to do this first, and then I went over the graphing methods, but the way I just go over graphing methods first, and then I go over the properties. These are basically the properties of graphing. And I'm going to sum up these by, going over a few things. Now, I'm not going to go over the Cartesian coordinate system, because y'all have all had pre-algebra and algebra 1. You've had 032 or math 101 here at Tri-County. So if you're in this class, 155, you've had a little bit of pre-algebra and a little bit of algebra 1. So you should know that the Cartesian coordinate system consists of x and y, with 0, 0 being the origin. Now, that first part you should know. The part I'm going to start with is slope. Slope can be or calculated. Observed, it can be observed with a graph, or it can be observed in an equation. It can be calculated when you're given 2 points, either by themselves or 2 points on a graph. So let me give you an example of how you find the slope with observation and how you calculate. Well, down below there, you see the general form of a line. the general form of a line is y is equal to mx plus b. So if you solve for y, m is going to be your slope. So you don't have to calculate it, you just have to find it. Okay, so if you solve for y, that whatever's in front of that x is going to be your slope. And that's how you observe it. Another way to observe it is if I give you a graph and I put a 4 here, or a point here, and a point here, and you got your grid marks back here, and you can count the blocks vertical over horizontal. So that's, I'm just saying 2 down, or 3 down, and 3 over. Then that would be 3/3, which is -1. So your slope is -3/3, which is -1. And here, y is equal to 2x plus 6. M is equal to 2, and m is equal to -1. So those two examples, I just observed the slope. I didn't calculate it. I didn't do a mathematical equation. All I did was I looked at it and I looked at it over here. I observed it. So if the directions say find the slope, chances are, if the directions say find the slope, chances are it's an observable type question. Calculate is going to say calculate the slope. It's going to say calculate the slope. And I can be given 2 points like this, 2, 4, 6, 8. Or I can be given 2 points on graph, 0, 5, and 4, 0. I can be given 2 points on a graph, or I can be just given 2 points. And sometimes on a standardized test, they'll give you a graph on a piece of graph paper that has the squares, and they'll just draw a line, and you find 2 points because it's on graph paper. It's easy to find 2 points that are, you know, like that point right there. I can find that point, and then this point right here, and then I can use those 2 points because they're on the corners of boxes. So, and kind of, that's basically it as far as the slope. So let's do an example. Let's do an example of both. Let's say find the slope. And find the slope means 2x plus 3y is equal to 8. Well, the first thing you got to do when you find the slope is you either, it's on a graph, you see it, or you got to solve for y to get it in that standard form. So 3y is equal, take that across the river, divide by 3, and y is equal to -2/3 x plus 8/3. Take my handy dandy highlighter, and my slope is -2/3. Okay, so that's one way to find the slope. And I'm not going to do the graphing because I don't have graphing. Well, let's see. Can y'all see those grid marks? Yes or no?
Sort of. Yeah, I can.
All right, well, I'm going to put a point right here. And I'm going to put a point right there. I don't think I can change the color of those. I probably can't. No. It just tells me, okay. And I'm going to draw a line between those points. And I'm going to have a line here. I'm trying to do this while I have to line up everything because I can't see the grids unless I'm looking at the. So I'm having to do this. Y'all better appreciate this. There we go. All right, so there's our line.
We do appreciate it.
Yeah, I know you do. Miss Hatton don't. She takes me for granted. All right, so here's my 2 points. And I'm going to drop that down. That's a what? Let's see. 1, 2, 3. That's 1 and 3. And this is 4 and 3 and 1. 3 and 1. Now I can draw a white line, right? I'll take my handy dandy yellow marker. And I'm just going to try to do this without a ruler. How many blocks is right here? 2. How many blocks is right here? 2. So my slope is equal to vertical over horizontal. So that's going to equal 2 over 2, which is 1. And it's in the negative direction, so that would be -1. So that's how you find the slope if you're just observing. Okay. Both of those are standardized test questions / questions I would give you on test. M is equal to vertical over horizontal, which is 2 over 2, and M is equal to 1. -1, sorry. And it's negative because, which way do we read? That means I want y'all to answer left to right. So put your little car right here. What's that car doing? What's that car going to do?
Go up.
It's going to roll downhill. Which way do we read? Left to right. It's going downhill. Downhill is negative. That's how you tell if the line is negative or positive. You put a car on the left-hand side and tell me what that car is going to do. That car is going to roll downhill. That means negative. So there is find the slope. Calculate the slope. And we're going to calculate with these 2 right here. So here's my points, 1, 3, and 3, 1. And slope is equal to delta y over delta x. That means the change in y over the change in x, which is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, which way do we read? Left to right. So this is x sub 1, this is y sub 1, this is x sub 2, this is y sub 2. Plug and chug, parenthesis minus parenthesis over parenthesis minus parenthesis. So what's y sub 2? 1. What's y sub 1? 3. X sub 2, 3. x of 1, 1. 1 minus 3 is negative 2. 3 minus 1 is 2, which is negative 1. Now I just calculated the slope. Do I use parentheses to this day? In other words, if somebody was to ask me a question, would I use those parentheses even though I've got several degrees? Yep, I would use them. Why should everybody use parentheses doing this? Because there's two things that y'all can't stand: fractions and negatives. And both of them will mess you up on a problem like this if you don't use those parentheses. So I always use parentheses on my calculation so I don't mess up with a careless mistake. So that's how you find the slope, and that's how you calculate the slope. Questions on that? And like I said, that's covered pretty much on the first couple of pages. Right now, I'm in the middle of page 2. Right now, I'm about right here. Now, the second most important question, or the second most important equation of properties of graphing is the point slope equation. Point slope equation. When do you use the point slope equation? When you have a point and a what? A slope. You also use it when the directions say find an equation. When you see those words in the directions, that means you've got to use the point slope equation. Now, there's 3 types of question you might get with this one. One, they may give you a graph and you find 2 points. You got to find the slope, then use one of the points and the slope and do the point slope equation. 2, they'll give you 2 points. And 3, they'll give you a point and a slope. Now that's the easy one. This is the easy one because all you got to do is plug and chug. These 2, you actually have to find the slope first. This one you just plug and chug. Okay? So let's do an example. Now, these 2 are done the same way. One is visual, this is visual, and this one is algebraic. In other words, this one, you look on a graph to get your points. This one, they give you 2 points. So number 1 and 2 could look like this, or it could look like this. In other words, they give you 2 points or they give you a graph and 2 points. Either way, you're going to do it the same way. So let's say this is, let's use what I've got in the example. 0, 4, and 4, 0. Now they could give it to you like this. They could give it to you with no points, and you have to, with the lines in the background, you have to find the points. Or they could just give you 0, 4, and 4, 0. They could just give it to you like that. That's these 2. Okay. So, and then you would calculate the slope. M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This is x sub 1, y sub 1. This is x sub 2, y sub 2. Because we read left to right. So that's your first set of x and y's and your second set of x and y's. 0 minus 4 over 4 minus 0. And that's going to be negative 4 over 4, which is negative 1. So I have a slope of negative 1, and I'm going to use 0, 4. Now you can use either one of these points. It doesn't matter. I just picked this one because it's on the left, and I read left to right, and that's the first point. And now you plug it into the point-slope equation. The point-slope equation is, I'm going to write it in red. I should have wrote the y minus y sub 1 is equal to m times x minus x sub 1. That is the point-slope equation. Point-slope equation. Point-slope equation. So y minus parentheses equals brackets, or m, times brackets, x minus parentheses. There's supposed to be a parenthesis here too, I'm sorry. So my slope is negative 1. My x sub 1, y sub 1, that's 4, and that's 0. Plug and chug. Now solve for y. Y minus 4 is equal to negative 1x plus 0. Bring the 4 over. Y is equal to negative x plus 4. And that is the equation for this line. All right, who's got a question? And again, a lot of this should be kind of like, a lot of you should be like reviewing. And I know y'all gonna go home this weekend, and you're gonna actually do it now that I opened up the homework. Most of y'all are gonna go home tonight and work on the homework and send me questions, and we're gonna iron out all the wrinkles between now and Friday. And that'll leave you with the weekend to do the test that I've already started. Okay? I started it today not knowing that the homework wasn't opened. So if I need to extend it, I will, but you should be able to finish it over the weekend. Okay, and the last part of the properties are these 4 properties right here. And I'm not going to rewrite these because these are pretty. I'm not going to rewrite them. I'm not going to write them again. There they are. If you are on a test and a homework and they give you x is equal to a number, I'll give you some examples. Well, I'll give you some examples on this page. X is equal to 6. X is equal to negative 4. X is equal to negative 1/2. Then they are going to be all lines. If X is equal to a number, then it's parallel to the y-axis. So therefore, it's a vertical line. Therefore, M is equal to undefined. So you plot the X. I'm going to do these. I'm going to do different colors. Let's do this one in orange. X is equal to 6. 1, 2, 3, 4, 5, 6. Draw a dot. And draw your line parallel to the x-axis. The next one is pank. X is equal to -4. -4, 1, 2, 3, 4, and draw a line parallel to the y-axis. And we'll do the last one in per day. -1/2 is right there, and it's a parallel line. And there is what happens if you're given an equation and x is equal to a number. And they say graph. The directions will say graph. If they say graph and you got x is equal to a number, it's going to be a parallel line, parallel to the y-axis. And vice versa, if it says graph and they say, we'll use 3 different colors. Let's use red. Y is equal to 4. Y is equal to 1/2, or y is equal to -1. And y is equal to 3/2. Well, what do you think if x is equal to a number is parallel to y, what do you think y is equal to a number is going to be parallel to? If x is equal to a number is parallel to y, then what is y equal to a number going to be parallel to? Okay, I'll show it to you again. If x is equal to a number is parallel to y, then what is y equal to a number going to be parallel to?
X.
Thank you. Okay, and m is going to be equal to 0 because it's a horizontal line. So let's plot y is equal to 4. 1, 2, 3, 4. And of course, it is a parallel line to x. Y is equal to -1. Plot that point. And it's parallel to x. I still can't get over that yellow. I can barely see that yellow on my sheet, but y'all can see it fine. That's wild. And the last one, y is equal to 3/2. Well, that's 1.5. And it's parallel to now those are simple problems. Please do not make it more difficult. Okay? That's all there is. If y is equal to a number, it's parallel to x. Parallel to x. If x is equal to a number, it's parallel to y. There's no x in here, see? Y usually it's y is equal to 4x, but no, if it's equal to just a number, just like these are equal to just a number, You're either going to have a vertical line or you're going to have a horizontal line. And then the last two things is those two properties right there. And you got to be able to find the slope. So you are going to have to solve, whenever you're given one of these, you have to solve for what? Y. And you're usually going to be comparing two equations. If you solve for y and the slopes are the same, then you have parallel lines. If you have opposite inverses from each other, opposite sign and the inverse, what's the inverse of 3? 1/3. What's the inverse of 2? Be 1/2. What's the inverse of 2/3? 3/2. And then in the opposite sign, then you have perpendicular lines. Now, what is the directions going to say on these? It's going to say find out if the lines are parallel or perpendicular. That's what the directions will say. And then it'll say y is equal, it'll give you two equations. And if they're solved for y, you just compare the x's, the m's. And if they do not have y by itself, you solve for y and find the m's that way. If they are equal, they're parallel. If they are the opposite reciprocal of each other, then they are perpendicular. Any other is neither. Okay, so if you have a 2 here and a 6 here, then it's neither parallel or perpendicular. It's either got to be equal or the opposite reciprocal. Question. Great. Complaint. Okay. That's 6.6. Now, am I going to get questions Friday? I should hope so. If I don't get questions Friday, then I'm just going to go over the test and move on to next unit. Let me look at nobody's got any questions. Y'all just going to let it sink in, right?
Yep.